So we've been working with differentiation and the power rule. Here are some of the rules to differentiation. So we have our functions on the left. So our first function is a constant. So constant looks like a number. So f of x equals c. To take the derivative of a constant, you're going to end up with a value of 0 because there's no power to bring down. The next one is a function that has x to some power. So here's what the function looks like. F of x equals x to the n power. You would do your power rule. You would bring your n down in front, and then this is your subtraction. If you have the next function, a constant multiple of x to the n power, then our function would look like this. F of x equals a to the x to the n. You would do your derivative function where you have your constant, and then you bring your power down in front, and then you subtract the exponent. If you have multiple terms, so here is a term, and here is a term, you would take the derivative of both of those terms. So let's go through some examples. So here's our first example. We want to find the derivative using the power rule. So we're going to find out what is the derivative of f of x equals 3x to the 4th plus 4x cubed plus 3x squared. So there are multiple terms in that polynomial. So we're going to use our power rule. So let's say dy dx equals, we're going to bring that power down in front, so 3 times 4x, and now we subtract the exponent, so now it's exponent of 3 plus power down in front, 4 times 3x, and now you subtract your exponent, so now it's a 2. Next one, multiply 3 times 2x to the first. Now we're ready to simplify. So dy dx, 3 times 4 is 12, x cubed, plus 4 times 3 is 12x squared, plus 3 times 2 is 6x. This should actually be a 2 here. So there's your derivative. All right, example 2, find the derivative using the power rule. So we have 2 examples here. The first function is f of x equals 10x. So we would bring the power down in front, which is still just 1. And then you would subtract 1 minus 1. So we get 10x to the first power. Anything raised to the 0 power is 1. So your answer is 10. Example B is very similar. Bring your power down in front. So 4 times 1. X. 1 minus 1. 4 times 1 is 4. X to the 0. That x to the 0 becomes 1, so you're left with 4. Example 3, dealing with constants. What happens to those values? Those derivatives will become 0. So here's your first function, f of x equals 10. It's a constant. So your derivative will be 0 because there's no variable. Second example, another constant. So your derivative is 0. Another example, example 4. This is where we have to start doing some steps to differentiate with a fraction. First, what you do is you look at this function, it's a fraction. So step 1 is we want to split up the terms. So f of x equals, and now you're going to split up x squared over x cubed plus 5 over x cubed. Then you want to simplify those terms in step 2. So if we look at this first fraction, you can reduce by a common factor of x squared. So that will become f of x equals 1 over x. This fraction, there isn't anything to simplify, so it's still plus 5x cubed. Step 3, change those fractions by rewriting them as negative exponents. So our function now is f of x equals, this is a power of 1. So when we write that as a exponent with a negative, it's 1x to the negative 1 plus 5x to the negative 3. Step 4, now ready to use our power rule. So, derivative notation, 1 times negative 1, x, and now we subtract our exponent, negative 2, plus 5, bring down your power, negative 3, x, subtract your exponent. Last step is to rewrite the derivative function with positive exponents. So derivative function, 1 times negative 1 is negative 1, divided by x to the negative 2 power can now flip down to the bottom as a positive power. 5 times negative 3 is negative 15 over x to the negative 4 power now flips down to the bottom as a positive x to the 4th power. Now I'm just going to change one thing. This is a plus and a minus. That will just change to a minus. So there's your derivative function.